Right, yeah, we can start now. That's fine. So thanks ever so much for everybody that's joining today. So before we start, there's a PIN number for Kahoot. You can either use the QR code or just type www.kahoot.it to join in on a mobile app. If you'd like to do that. Obviously completely voluntarily, but it's just a few questions as we go through the session today. Okay, so we'll start now. Right, so we're looking at discovering vehicle incidents hotspots. So that's basically what we're doing today. So my name's Becky O'Connor. So I work at Snowflake. Just an interesting fact again, because it's to do with incidents and accidents. I have failed my driving test 9 times. I passed on my 10th attempt. So very very real for me anyway. I don't know anybody else who's failed as many times as me, unless somebody else can raise their hands, but that was basically my fascinating fact. We've got Janet here as well. So Janet works Janet, would you like to introduce yourself actually?
Yeah, I'm Janet Broom, and I work for Snowflake. I manage the NHS central accounts, and I manage our the Snowflake relationship with Analyst X, which we're really happy to be able to support today.
Okay. Right, so if I just go to next. Right, so the things that we're going to do in the hour. So we're going to look at the kind of like the apparent worst places to drive according to where they're located. So we're going to look at latitude and longitude. We're going to look at bringing data into towns, into areas and polygons. And we're talking about shapes. So let's talk about hexagons, distances away from different locations as well. We're going to cover hotspots. We're also going to do some predictive analytics as well. And the 7th, so you'll notice there's 7 points here. I'm going to ask a total of 7 questions during that time. So 7's a bit of is all to do with the 7 values, 7 pillars of innovation. So Snowflake is geared towards these 7 pillars of innovation. And to be honest with you, the session today, I'm going to touch lightly on pretty much all of those pillars. So we're going to be bringing in stuff from the marketplace. We're going to look at all different sorts of data, different programmable. So we're going to be utilizing different programming languages and things like that. It's and all different and data engineering, data apps, etc. So really, without all of these pillars, I wouldn't have been able to have created the demonstration that we're going to be doing today. Okay, so if I just go to the next screen. So first of all, on this quiz, so according to a blog on Wessex Fleet, which is the worst city to drive in England? So we've got a few seconds left. Right, so most of you think that it's London. Now, by the way, this isn't kind of what the government has said. This is what some blog has said, according to Wessex Fleet. And apparently, it's actually, well, Data Rider, so whoever that is, has won that particular question. So let's actually find out and see that in action. So I'm going to have a look at the app. So this is a Streamlit app, which is an application that Snowflake is powering. So Snowflake is actually powering this particular application, and we can see that number 1 is actually Bristol. If I click on the link, I can see there's an image of Bristol. I just want to say that the image itself is actually saved. It's unstructured data is actually put inside of Snowflake, so you can see that from Snowflake. We can see some key statistics, for instance. We can see what the worst junction is, and there's some source, some information about the M32 junction in there as well. And there's some info as well, and I'll go into that information later. But there's a few, there's some data that's actually coming from the government data, which I'll show you how I brought that in as well. But there's other ones as well. So if we wanted to have a look at, say, Birmingham, for instance, so that will be number 3 in here. And then if I hover over number 3, I can see some details about Birmingham as well. So let's just put it back onto Bristol, because I'm focusing on the worst city. If I then have a look at how that looks like within Snowflake, so if I just have a look at the top worst cities to drive, so I've put these in. So these are the different towns. As I said, there was 7, so I've put it against the 7 pillars of innovation, as you can see in here. And I've got lots of different statistics that's come from the website in here. We've also got latitude and longitude, the points, basically, and some various other bits of information. Now, if I wanted to use the points as to something that's recognized, so you'd be able to calculate distances and be able to create polygons and things like that, I would simply use a function, a built-in Snowflake function called stMakePoint. So here I've now got everything now into points in here. So if I wanted to, so again, this is just a very basic Snowflake function that's completely built in. We can see those points in there. And that's just one example of a function. If I go to all the geospatial functions on the Snowflake documentation, you can see all the different types of geospatial functions that you can utilize within Snowflake. Okay, but that's not all you can do. And again, I'll tell you that again, more about that a bit moment. So the next thing I want to have a look at, well, the data, the map that you saw was based on some media blog. I'm not quite sure whether it's completely and utter factual or maybe slightly fictitious, who knows. But I wanted us to have a look at some kind of maybe more reliable data. So I'm having a look at the accident data. So if I just go back to Kahoot, just to show you where I got that from. So look at the road safety data. We've got some Department for Transport data, and I brought all the data for accidents, vehicles, and casualties across all the years. So if I go back into here, we can see I'm looking at a sample of 1,000 rows of data. We can see the shape of that data, for instance, in here. And we can see there's got like some road type. They're all numbers because the way the data is presented, we're not looking at the descriptions of the different column headings. It's kind of like an identifier for what all these things are. So we probably need to know what those actually mean, and we'll have a look at those in a minute. But one of which is there's latitude and longitude in here somewhere. There's also, you can see longitude and latitude. There's also police force in here as well. And as I said, that's just a number at the moment. So we may want to have a look and see what that number actually means. So thankfully, that data set also comes with a lookup table. So it tells you what all of those numbers actually mean. So this one, there was a particular one for police force, and we can see number 52 is actually Avon and Somerset Police. So although it doesn't have the town in this data set, it does have the police force. So we can say, so we can look at, in a roundabout way, for Avon and Somerset Police, we can work out how many, for instance, how many accidents there are. So before I have a look at how many accidents there are in total for Avon and Somerset Police, if I just go back to Kahoot, and let's do a quick quiz. So according to my analysis, how many accidents have been recorded by Avon and Somerset Police since 2001? So there's 6 possible choices in here, and you've got 20 more seconds before you have to answer it. And we'll have a look and see what's been answered. Got 10 seconds left. But as I said, it's not just the city itself, it's the police force. So it could be the surrounding villages, for instance. So in fact, the answer was, so we've got, if we go back, go to the next page, data writer again is in the lead. And if we have a look and see what the actual answer is, so I go back into my back into Snowflake, accidents within Bristol, and we will be able to see that yes, it is, well, 81,000 in total. So you'd see what that actual answer is. If we wanted to look at that across all police force, if we wanted to, we can do that as well. So we're joining that to our look table, basically. But as I said, we've got the data for the police force that contains quite a lot of areas. So it contains all the little towns and the villages around Bristol as well. So we might want to be a bit more specific. We might want to have a look at just that specific town and city. So this is where we can start utilizing polygons. So what I've done is I have ingested a the polygons for all the different towns and cities as well. And each town has got a corresponding geometry. So this is, if you're not familiar with geospatial, it's literally joining the dots. So all these are different locations with latitude and longitude coordinates, and it's actually making a shape. So it's a shape of Basildon, Bath, Birmingham, etc., etc. Okay, so by using that polygon and also using the points that we had before, we can say, well, whenever that point goes inside that polygon, can we code that into a town? And that will then give us that town as an additional column in our data. So now previously the accident data set didn't have towns. Now it does have towns. We've got all the different town names. So we're now able to have a look and see what the number of accidents are in a particular town, as opposed to just a police force. We can also, if I go and select a specific, selecting the town name, so selecting one column, this particular function here, st area, that actually gives you the how big or how small the geometry or the town is in relation. So in order, so it gives you being able to put an area in place, you can basically work out how many accidents there is in relative to the area, the size of the town, basically. So we can look at the number of accidents, the size of the town, and then we can see the accidents weighted by area of town. So we looked at towns, but towns is just one type of polygon. So for instance, I've got integrated care boards. So we're going on, say, to NHS data for in the integrated care services. We might want to see how many accidents is there within an ICS, for instance. Now, this particular database here, I'm just hovering over now, is actually a data share. So there might be another account, another organization that's got different boundaries that I might want to utilize. I don't want to ingest it again and again and again. I don't want to keep having to reload the data. So I'm just simply sharing that data from that other organization. I'm now able to utilize that polygon to be able to see how many accidents there are in relation to the population. So we could use and then to have a weighted score rather than just counting the number of accidents per ICS, because obviously you may want to weight it based on the size of the ICS or the number of citizens inside that ICS as well. So then if I then go back to the Streamlit app, just to see that it kind of more in a kind of like in a diagram. So we've talked about shapes, we've talked about polygons. So I actually want to see, well, what does that actually look like? So looking at the polygons themselves, those were the towns. So those were the major towns that we were actually looking at, and then if I go to like the ICSs, for instance, in here, we can see the ICS polygons as well. But before I carry on, I'm going to create, there'll be another question for you. So according to Becky's data analysis now, so which town has the most accidents but weighted by how big it is? So let's take into account how big the town is, but let's just think about how many accidents there are. So in the look, almost like the density, really, isn't it? So you know, London is obviously quite clearly a very big city, but so there'll clearly be more. But is it the most when you're looking at people in perspective? So let's have a look and see what you think. So we have, if I just go to the next page, and Data Rider again is in the lead on that. If I go and I don't think anybody got that one right, actually. So let's actually go and see that in action. So if I go back to the back to the Streamlit app. Now, if you were quite savvy, you'll be able to see. So this, just before I go into a bit of detail, the visualization I'm actually loading is actually a Tableau visualization, and as I'm changing the filters, it will actually change, dynamically interact with the Tableau dashboard as well. So you can see that there's an orange circle which is much bigger than the others. And if I hover over here, if I just close the navigation bar down for a moment and just press that, you'll be able to see in orange that Brighton and Hove was weighted, had the highest score. So that would have been the right answer. Now, you might want to know, well, why is some of these in orange and why are the rest of them in blue? Well, you'll notice that there's actually 7 orange bars, and that's because those were the original 7 bars, the 7 cities that were featured in that 7 cities article. If I go and have a look in here, though, we can see there's a lot of blue bars. So the one that came second, which was London, so came third Portsmouth and Manchester. These top ones here didn't actually feature in the worst cities at all, according to that article, which I thought was really interesting. However, it wasn't just talking about accidents. They also were looking at lots of other different statistical measures as well. So who knows where they got that particular answer from. So let's have a look in a bit more detail on the integrated care board. So just go and select my year. So I'm selecting 2021. And as I say, again, this is another Tableau report. As I'm changing my year in the Streamlit application, it's now rendering the report. Again, all the data in the background is all driven by Snowflake. If I click on one of these, so I'm going to go to the Lincoln Integrated Care Board, for instance, an example, we can see that where they're featured in terms of comparison to other ICSs, and we can also see some other bits of information regarding casualties versus fatalities, etc. Now, down the bottom here, we can see that this particular area, Lincoln Integrated Care Board, I've drilled into it, and if I zoom in, you can see that these aren't circles; they're actually hexagons. Okay, and the dark hexagons is where there were some fatalities in the area, and the light hexagons was where there's casualties, but there hasn't been any fatalities in that particular time frame. So again, if I go back to Kahoot, and let's go to the next question. So first of all, if polygons, what if polygons could all be the same shape and size and could all fit together nicely? Could we make it nice and consistent so we don't need to weight things based on how big something is, how small something is, because everything's the same size. It's all hexagons basically. So just as a quick quiz, this one's a bit of a just for fun quiz. So this wasn't one of the 7 questions. So what's the name of the quiz show in the 80s and 90s that had hexagons in it? So 10 seconds left. And I think whether it depends on your generation as opposed to whether you know the answer to this question or not. My daughter hadn't a clue. Everybody got the answer right, interestingly enough. Oh, bar 1. So they might have been a bit younger, too young. Okay. So everybody's got a few points here on the leaderboard, apart from Andy, unfortunately, not on this, but there's still points to go. So Blockbusters was obviously a tea time kind of show in the 80s and 90s, where you had to join hexagons together to form lines, either horizontally or vertically. Now, hexagons is really useful from a geospatial perspective, and for some reason, when I started looking at hexagons and H3, the first thing I thought of was Blockbusters, as you can probably imagine. But H3 is basically Uber's hexagonal hierarchical spatial index. So you can basically put hexagons inside of hexagons, inside of hexagons, inside of hexagons. There's lots of levels in a hierarchy from resolution 1. Each level is called a resolution. The higher the resolution, the higher, the smaller the hexagon is. The lower the resolution, the higher the resolution is. And it's got a hexagon as a hexagon allocated to every part of the Earth. And it's been open sourced since 2018. So quick quiz. So what is the approximate area of a hexagon in H3 when it's set to the highest resolution? So it could be smaller than a car, or could be bigger than a house, bigger than a swimming pool, smaller than a foot. So think about the highest resolution. We're looking at, there'll be a unique identifier for every hexagon in that high resolution as well. So the answer, in fact, unfortunately, nobody got it right in this case. It was actually smaller than a car. So if I go to my next page, so the H3 resolution, so number 15, 0.0009 is actually just under a square meter in size. So let's try and visualize what that would actually look like. Now, I did a little bit of Googling to try and find something that would be of that size, and I came up with this, which is a hexagon of a sandpit. And unfortunately, it wasn't 0.0 square. So the lowest resolution is actually smaller than that sandpit. Okay, so, and the child kind of gives you the idea of scale. So imagine one of those sandpits covering the entire planet. That's basically what H3 has done with the highest screen, with the highest H3 resolution. Okay. So if I go back to the next page, so in terms of the demo that I've been doing today, a lot of the H3 resolution I've been utilizing is at number 7. So every hexagon is roughly 5 kilometers square, really, and you can see the number of indexes as well. So there'll be 98 million indexes in that resolution. Now, the great thing about H3 is if you have all your data sets in using a spatial index such as H3, and there are others, you can join data together based on those spatial indexes, and it just makes the processing capabilities so much better and quicker, because you're aggregating it at that higher level, and you're just simply joining hexagons together. And you can also fill polygons with hexagons, as opposed to just assigning a point to a hexagon as well. So if I just go to the next page, and let's have a look and see what that actually looks like. Now, Carto is a partner of Snowflake, and they actually provide an analytical toolbox, and that's within the marketplace, and it's completely free. And it's basically a series of functions, and some of which are our H3 functions. So one of the functions, as an example here, is a polyfill function. So in other words, you have your polygon, you have your town and what the shape of that town is. We want to populate all of that into as hexagons at the whatever resolution. So in this case, at resolution 9, I'm going to polyfill this geography into as hexagons, and then I'm simply joining those hexagons with my points, which are also turned into hexagons as well. So going to have a look at let's have a look at the within Snowflake, within the Snowflake workspace. So I showed you an example of polyfill, but also you can use points as well. So I'm utilizing the Carto functions to assign all my accidents based on where they are, based on that point. I'm assigning them all to these consistent index keys, which have geometries, and the geometries pretty much all the same. They're all basically hexagons, which you can utilize in, say, Tableau, for instance, or other visualizations tools. Okay, so yeah, so simply you'll be just joining them together as opposed to doing spatial joins, basically. So if I go back to my Streamlit application, and if I go to my my city details, for instance, you can see there's a heat map, for instance, of Bristol. And I've got here, I'm selecting my H3 resolution, which is at 7. And these are all of the hexagons that make up the whole of Bristol at resolution 7. And I can choose different measures. At the moment, I'm choosing casualties in this particular example. I've got casualties versus the age of driver versus the average age of casualty as well. Also, I've got casualties versus female drivers. So again, I'm just all of these dots in here. I've just realized I shouldn't have done circles. I should have done hexagons, because each one of these circles actually represents a hexagon. Okay, so one of these hexagons, and I've put into these on the map. So I wanted to also look at another function that Carto provides. Now, this isn't H3, but I put it in there because it's relevant to Carto. So an additional function that Carto has. So if I go into Carto, you'll be able to see within the analytics toolbox, you can have clustering in there as well. So I've created some simple clustering, just looking at all the different points. So rather than putting it into hexagons, I'm just going to the lowest level, looking at all the points within Bristol, and I can see that I've got 6 clusters, because that's what I've decided to cluster it in, and I've got a different color here that represents each individual cluster. I can also, I'm filtering by town, but I could, if I wanted to, filter based on radius, for instance, so based on the radius of the center point within a city. So a simple Tableau standard, not Tableau, sorry, a simple Snowflake spatial function called st-centroid allows you to work out where the center point of a polygon is, and so in this case the center of Bristol, for instance, and then we're looking at how many accidents there are within that radius of Bristol, and then it's going to work out what the hexagons are based again on that resolution of 7. And again, we can look at the accidents versus age of driver, exactly the same as we saw before. And if we go down further to the bottom, I've kept a more detailed table that actually breaks down. You probably wouldn't normally visualize it in this way, but I just wanted to show you just so you can see. We've got each individual unique index. So this is what each hexagon is relating to. And again, we can see what the numbers are, age of drivers, etc., etc. Okay. We can also have a look. So we're looking at towns. So let's move away from towns now. So we're looking at radius within the centre of a town. Let's have a look at incidents within a radius of a fire station, for instance. So I'm looking at a fire station in here. So let's go to Avon, for instance. So I'm selecting Avon, and the reason why I'm selecting Avon is because Avon Fire Services is within the Bristol area, and that was what we've been focusing on. And we can see that there's some locations of vehicle incidents within there. But again, if I wanted to change the range in meters to be more than that, I just change the range in meters. Again, in Snowflake, that's recalculating that data to then see we're going to see more vehicle accidents within like a higher radius, and we can see all the fire stations, the casualties, and the incidences in there as well. Okay. Now we've got another one here, and I'll just show very briefly, but I don't want to show too much because I don't want to give too much away because there's another question. So this is going to lead to another Tableau report. So if I go back to my next slide, or a quiz, should I say. So in 2020, according to Becky's analysis, so which gender has the most casualties within the Avon Fire Service boundary? So what do you think the answer is there? So are there more males that has the most casualties, or females? So maybe it might, I guess. Okay, and yes, the three of you have in fact got that right. So there's actually male was the right answer. So we can see that we've got some more people on some more points here in the scoreboard. So if I go to the next section in here, so if I just go and have a look and see what that looks like. So go back to our app, so our Streamlit app. And going back to my all incidents within a fire service. So if I go to the all casualties, so I'm looking at all casualties. We previously selected Avon in the previous tab, and Tableau, as I said previously, it's going to automatically interact with these filters as well. So I don't need to filter it again inside of Tableau. So within Avon, I can see that, yes, in fact, there are actually more males than females. So we might want to have a look, rather than just looking at all casualties, we might want to have a look at just at the ones that were actually fatal. So again, we'll just have another question on here before before I reveal that. So according to Becky's analysis, so which Avon Fire Service area, which day of the week has the most fatalities? So we've got all the days of the week apart from one, because unfortunately I couldn't work out how to do 7 possible answers in Kahoot, so we've only got 6 possible answers. So so the clue would be it's definitely not Sunday. Okay, so we've got a few seconds left before we get to the answer of that. So 1 got it right. Okay, so it was in fact, okay, so Vic is now in the lead. So if we go to the next page, and let's have a look and see what that looked like. So rather than looking at all casualties, let's have a look at our fatalities. Again, this measure, this within Streamlit, again, which powered by Snowflake, it's actually interacting dynamically with the Tableau page, and we can now see that the most incidents is in fact on a Saturday. Okay, so the final thing we're going to have a look at, so look at this last one at the top. So this is another tab. So we're going to predict some casualties near a fire station. So within Snowflake, you have the ability to bring in lots and lots of data, as you can see, lots of different data formats. You have the ability to train data from an AI perspective in order to create predictive models. And I've done a very simple predictive model in here to kind of predict number of casualties. And I've got like a model predict So I can either choose my casualties model or my high fatality predictor. Now, because I didn't have lots of data, I wouldn't say it's the most accurate of models. However, you would get the general idea of what the art of the possible is, what you could potentially do. So I'm selecting Avon Fire Service in here. My model predictor in here is my casualty predictor, and I'm selecting the number of hexagons away from a fire station. So I'm going to run my predictive model in here. So that's actually going to run a predictive model. And while it's running, so I'm just yeah, so as we can see, please wait for casualty predictions. It's now running the predictions. So before I do that, I just wanted to give you an idea about what that actually looks like. So in terms of like the setting up perspective. So I did some, as I said, some feature engineering. So I used all these values as a way to create my predictions. So that was my my feature table basically. I then used, and again, I'm not using SQL in this instance, I'm actually using Python. So again, going back to the 7 pillars of innovation, this is the next language that I'm actually utilizing. I'm actually creating a training model. I'm training the data. And then lastly, I'm inferring that schema, inferring it into Snowflake as well. So basically, what it will do is it will create a function that I can then use in my Streamlit app. So in this example, I've already tried out previously. I'm selecting my new function, and these are all the values I put in. But obviously, you don't really want to use a function just using SQL code in Snowflake or in Snowsight. You probably want to do that within an application, which is what I've done here. So each of those answers is by me selecting, utilizing my sliders, utilizing my drop-down lists, etc. Okay, so before we get to the kind of like the answer on that perspective, so if I go to the next question, so if I press next, so go to another quiz. So which weather condition is predicted to have the most casualties near Southmead Fire Station? Okay, and I can't remember which fire station I put in that predictor and whether or not I put the right one. So, but I've definitely got an answer within here. So, okay, so let's say so. Okay, so we've got 2 of you have put fine and high winds, and then another 2 have got fine with no winds. So if I just go to the next one, so let's have a look and see what that is. So if I just go to the go back to my Streamlit app. So now the predictive model has now ran. We can see there's total predicted casualties, the probability of predicted casualties. We can see that within looking at incident hotspots in here. So we can see that there's going to be more over here. Maybe that's near the M32, for instance. Maybe it's over that really bad junction, for instance, where there's lots of casualties. Casualties by road type, etc., weather condition, and then we can see, looking at the weather conditions, we can see that there's actually fine and no high winds. So when you have a really nice day and the weather is nice and there are no winds, then there's more likely to have an accident than all the other weather conditions, which I thought was quite interesting. But again, this is just my kind of rough analysis. We probably need to do a bit more investigation to get like what the actual what the truth would be in that. Okay, so if I go back to finally go back to Kahoot in here. So if I go back to here, and so finally, so I've looked on the messages thing. There's a few people in the on the meeting chat. So are there any questions? So if anybody wants to ask any questions before we look at the kind of like the winners ranking, for instance, within this, if you can type the questions in the chat, or then you can or not. Okay, I'll just wait a few more minutes to see if there's any questions. Okay, so there doesn't seem to be any questions. So if we then go to my next and let's have a look at the results. So going onto the podium, so we can see that third place is David Ryder, and second place is Timmy, and in first place is Vic. Just as a you know, and then there's some runners up as well. There's Lisa and Andy in 4th and 5th place. So thank you ever so much for playing, or even just listening if you'd rather just listening. So yes, so thank you ever so much. So I will